So this talk is pretty different from most of the talks at the conference. It's not another use case. It's not how to use Temporal. It's not what Temporal does today. It's a vision, okay? And how to think about Temporal, which I believe will help you decide what problems to use Temporal for. And it's not for everybody, so food for thought, not the answer to anything here. It's also the fulfillment of a promise I made a couple years ago, because as Dave pointed out, I talked about the vision for Temporal then. At that time, it was controversial that Temporal was building not just a workflow hosting platform, but an operating system for building applications and for the whole cloud, in fact. And I talked about that, and I believed very strongly in what I was saying, but I didn't have concrete details about it. And so even though I'm not going to be able to make promises about things Temporal is building right now in this talk, this is forward-looking without the promises. But in terms of the vision, I think it's very accurate. I think it's something you can count on. So this talk is about abstractions. I'm a very abstract thinker, and I approach every problem first by saying, what's the right abstraction for this problem? I even think about the abstraction of abstractions, which is what this slide's about. The engineering abstraction, how do you do good engineering? Well, you choose the right tools, you build the right components, you have subcontractors. Even in the mechanical world of construction, you have to approach the problem from an abstract perspective, or you can. So it's turtles all the way down. In particular, and I also think about how abstractions in the software world parallel what's going on in the biological world. And I'm going to be returning to that over and over again during this talk because I think it's both illustrative and it helps frame your thinking, and it's just kind of fun, okay? And this talk is intended to be a little fun because I don't have to get into the nitty-gritty details of an API and so on. So when I talk about software organisms, and I'm going to be talking about it a lot, I'm referring to the user code, okay? Not to the operating system. I think of the operating system as the environment in which your user code is running, okay? Code that's got some purpose that you want it to do, whether it's a bank transfer, a mortgage application, or run an AI model, whatever it is your software is trying to do, okay? It's illustrative for me to think about the software as a species and then the organisms as, like little creatures, okay? So, and like any tool, the abstraction of software organisms, if you have to understand it if you're going to use it. Tools have to, the better you understand them, the better you can apply them. So, if you look at historical abstractions, if you look at history of software design, there's a few things that I want to point out as being critical, epochal abstractions, because they changed everything, okay? I don't even know this, but at the beginning, operating systems weren't shipped with machines. You bought a computer and you had to write your own operating system, right, to use the thing. So, and when operating systems started shipping with hardware, that was changed everything for the people using them. It made them so much more productive, okay? There were standards. You could use a computer at one company and go to another company, and you knew how to use it because it had an operating system. Changed everything. For me, the object-oriented programming paradigm was one of these epochal abstractions. So I started programming a long time ago, longer than most people. 1973 is the first year I got paid for programming. And so when object-oriented programming came along, I was astounded, and I thought, this is so cool. It makes it so much clearer how I should organize my software to accomplish the solution to my problems. Okay? Another paradigm which had changed everything. I also had a hand in the development of the service-oriented architectures. I was at Amazon in 2001 when Amazon converted from a monolithic single-process application, and I was in charge of the project, to build a service-oriented website framework. And again, that changed everything in the software world when we switched from just writing applications, single process, and so on, to a service architecture. Okay? And I want to point out something critical here is it wasn't just that the software changed, the environment changed. Okay? The kinds of services provided by the environment to the applications, to the services, RPCs, language neutrality, service contracts, decoupling not just of the software, but of the teams working on the software. This changed the world of software development, and it's led us to where we are today. The world of software today is mostly, and probably most of you are working in an environment that's in some fashion a service-oriented architecture. Certainly if you're using Temporal, you are, because Temporal is an outgrowth of that, okay? But the point I wanted to make here is that as the environment and the organisms living in it become more closely coupled, they affect each other. And the environment becomes richer, and the organisms can specialize. And it happened in biology, too. Okay, so we're going to keep coming back to that. So if you think about the evolutionary path and how the environment and the software running in it have evolved, you can see that Temporal is taking a new step along this evolutionary pathway. We're providing more and more services to the workflows running in today's temporal clouds, right? And there's already more than just workflows, so there's not a whole lot more than workflows. There's schedules today, but we've also started building communication components that are included in the environment of the software, and that's what you've been hearing about Nexus. Software organisms can't exist without an environment, okay? And not just the operating system, but also the other components that you rely on, the debugging tools, the tracing tools, visibility tools, et cetera. Right? It's not just the operating system, it's the whole picture around the operating system. I call this the software ecosphere, okay? Just so I can talk about it mostly. And I'm proposing that, I'm here to tell you that I believe that we are at the beginning of a new epoch of software development. Not just an improved operating system, not just an improved tools that you use to develop workflow-style applications, but that the ecosphere, if you think about it, is going to open up a new realm, a new universe even of software development. So let's talk about that. If you're going to evolve the ecosphere, and remember, we get to choose our evolution. It's not random, or at least not as random as biological evolution. We should think carefully about how we can make it better. So first thing, how do you make it better? You need to think about what was missing from our existing SOAs, service-oriented architectures. Okay, so here's my hint. For those of you who have read Hitchhiker's Guide to the Galaxy, what's missing is purpose, okay? I don't love this word, okay? It was the best word I could come up with. I'm not talking about business purpose, like bank transfer or so on. I'm just talking about purpose in the context you think of life having a purpose, okay? Your parents didn't know that you were going to grow up to become software engineers, but they still knew that there was something you were going to accomplish. You were here for a reason, in a sense. And they encouraged your growth. They provided you an environment where you could grow and thrive, stand you up if you fell over, give you education, and so on. And the environment shaped the possibility of humans to be what they are today. And if you, as a baby, you were thrown out, you were born and you were thrown out to live or die, you wouldn't be here, right? We're not bacteria. In a sense, today's service-oriented today's SOAs, ordinary operating systems that are out there, are kind of like that. When Linux starts a process and the thing just dies, does Linux even know or care? I mean, abstractly, there's an error code, maybe, and even then, but it doesn't have any concept of what success means for starting a process, which is as close as you can get to an organism in today's software environment. So I started thinking about this and started feeling, what does this mean to us? It's not, it's just, it seems like maybe a small thing, but it's quite powerful, okay? We have software with purpose, and we call it workflow, okay? It's going to do some work. It has a beginning and an end, kind of like an organism, right? It's born, it accomplishes something, it goes through some states, and when it's done, we know it because we've designated states of the workflow. Purpose is to get from born to dead, and then we bury it. So this is a powerful concept, and this much understanding, if this much interaction between the organisms and the environment enables a whole bunch of really powerful things that Temporal's cloud environment, open source server, either one of them does for you as a workflow developer. All right, so it seems kind of fun, but I'm still waving my hands, okay? But I'm about to stop doing that because I'm about to turn this into something concrete and real for somebody who thinks about systems, if you think about them the way I do, at least. I mentioned that my favorite paradigm shift, my favorite epochal abstraction was the object-oriented programming. So, because it's, for me, the most powerful abstraction, the best tool I know how to use to look at systems and problems. So I did that for workflows, and I came up with some ideas about what makes a workflow in a concrete sense. What are the concrete abstractions that a workflow has, right? And I said, so there's no surprises here for you, but I'm just making them concrete and listing them, precisely, okay? A workflow has lifetime. A workflow has an identity. It has a key. It has a reincarnation style lifestyle, right? Because a workflow can be completed, even whether it's dead and buried or whether it's still visible to you, depending on its expiration. We can start a new copy of that same, so reincarnated workflow. These aren't right or wrong abstractions. These are just the ones that chosen by Max and Samara, really, when they created the workflow concept for Temporal. They built this in, okay? So I'm not trying to create a perfect abstraction. I'm trying to create a really powerful and useful abstraction, but I'm trying to make it concrete so that we can think about what it means for how we design our software and where we apply this tool to our problems. So out of this, we also have some things that seem maybe a little more, could vary from one species of software organism to another, right? You can, for instance, imagine a workflow that didn't need any persistence. If it was just fine, like on your developer box, where you didn't need to have the 16 nines of reliability that the information was stored, you could turn that off for a workflow if you wanted to. But workflow has a clearer thing. I don't want to change workflow. What I want is to have something that's more of another class that's like workflow. So I started thinking about all of the concepts here that I've described for workflow as if they were concepts of a base class. Okay? So I had to make up a name for this, and I called it workflow is a state machine aspect, and everything in this sort of feature set that I've described has some sort of state machine feel to it. So I said, okay, it's a state machine, but that's so general. Everything's a state machine. So I want to use it to build my applications. I'll call it an application state machine. At one point, I called it an applied state machine. It doesn't matter. It's just a name, so we can talk about it. Concretely, though. Okay, so ASM. And you can take the same list of functional points, if you will, behavioral aspects that I described to workflow, and say, well, let's just say that's the base class behavior where the derived class can override some of it. Okay? Or the derived class can take advantage of it or not take advantage of it, depending on the use case. So I split that list of sort of functional abstraction points of this ASM class into a base and a derived section, and said, okay, well, everything has to have a key to make sense in this organism paradigm, in this organism thought experiment. It has to have atomicity. Remember, I care deeply about the ability of the environment to interact with these things, so they need some consistent features. So I broke this down in this fashion with lifetime identity, et cetera, as something that every organism in my new world, in my new ecosphere, can have, and then I can let the author of the class, you guys, decide if you need the optional aspects or, in some cases, how you would apply the concept of the optional parts of the thing. Obviously, the API of a mortgage application is different than the API of a bank transfer is different from the API of a sandwich order, at Kentucky Fried Chicken. So those are things that you should be able to specify as your API and remember that we've talked about APIs already in this conference, and so we're going to come back to that, how the APIs here correspond with the APIs of Nexus. Okay, so ASM, a base class for workflows. What can we do with it? It seemed to me like an incredibly useful concept because one of the reasons that I went down this road and end up on this stage to have this discussion is because there's a lot of places where workflow doesn't work that well. If you have a workflow that you want to contain signals and the signals are 4 GB each, you can't send them to a workflow, and you can't, if there's a million signals, God forbid a million that are each 4 GB, right? You can't use a workflow to contain them. Right? But what if you had a class structured just as a data container, okay, that fit perfectly into the temporal environment? You could say new data container, and then you could send it data, and it would hold it for you, right? That'd be a super useful tool for some of you, right? No tool I could possibly imagine could be as useful as workflows because it's sort of like the superset of everything that we know how to do, right? But it's not efficient at everything we know how to do. And if, for instance, you could have a collection class. You know, those are really nice when I write my Golang code, right? I wish I had a collection class for workflows, right? And then I could say, okay, now kill every workflow in my collection, bang, right? So you can envision a workflow class, but still that meets the paradigm, the abstraction of these organisms, temporal organisms, in fact, that so then I could have something like a batch manager workflow, okay? And it would contain a bunch of child workflows, right? Just like a human organism contains a bunch of cells, I can have my batch manager with a bunch of children, and then I can ask it, what's your progress? Or kill everybody, or hold on, put this on hold while I any of the operations you can think of. So probably we're not talking about one batch manager abstraction, ASM. We're probably talking about several with sort of different characteristics depending. Things you'd write yourself or possibly things that Temporal would provide out of the box as components that you could plug in. And if I think long enough, I mean, I had to stop thinking about it because the list of possibly useful ASM abstract classes that I could build was longer than I could, it's like I end up spending all my time doing that instead of writing real software. So the code, right, and the APIs is part of the code as far as I'm concerned, and is the DNA of these organisms. And you get to design this, okay? And you get to design it today because there's pretty much nothing you can't do with a workflow. So if you think according to this paradigm, if you like this paradigm and it turns out to be a useful tool for you, because I've never claimed it was right or wrong, just possibly useful, but useful to me, then you can start designing your applications in this fashion, and you will find that they fit into the future world of Temporal. As Temporal expands the capabilities of its environment and gives you more tools for managing not just individual workflows, but groups of workflows, as it gives you better visibility into and classification. You can imagine something that collected workflows as a batch, or not as a batch, but as a collection class based on whether they succeeded or not, or based on whether or not they met some business characteristic and you wanted to categorize them in that fashion. Or maybe you want to do a computation across a stream or a collection of workflows. Okay, that would be very useful in some business contexts that I personally have worked on. You're the intelligent designer here, and this is sort of a way to think about the problems that you apply Temporal to, and a way to shape the future. Okay, and as I said earlier, the organisms, and in this case, you're kind of part of the ecosphere, right? You're the gods of the ecosphere in this case, but you're still part of it, and you get to shape the ecosphere itself. Okay, and in this case, you can shape the ecosphere by sharing with us your needs and the missing features and the components that you wish you had in this temporal world, and we will listen, because that's the hardest part for us, is figuring out what's important to you. So this abstraction, for me, was a clear win for over what we've been thinking, how we've been thinking about temporal in the past. I decided I would call the operating system that included this sort of richer and more complete interconnection between the environment and the software. I called it the evolved cloud operating system, and ecos. And it's enough for me to call it an entirely new family of operating systems, okay? And Temporals is the first version of it that I know of, but I expect that this concept, because I think it's so powerful, will evolve past Temporal too, and other people will set up evolved cloud operating systems that provide much richer set of tools and support for the applications running inside it, for the organisms in their universe. But I did still believe that there was one thing missing from my picture, and fortunately I didn't have to think of it because I was busy thinking about ASMs. Max, came along with this concept of nexus. Okay, so what's missing at the functional level is a richer set of cooperation and communication abstractions and tools. Right? So if you're going to have organisms with this lifetime thing, with this life purpose thing, you want them to be able to interact with other organisms and in a conscious way of the fact that the other organisms might be long-lived too. And to make a communication, to establish communication with another organism where you can't count on it being instantaneous, you need the long duration communication style. Nexus provides that. So cooperation between software components, and I don't just mean individual workflow components, cooperation between, let's say, a collection component, that like two different batches very much might want to validate that they aren't going to be competing for the same resource. They might need a semaphore for something, for managing resource contention or something like that. But you need a communications infrastructure that allows you to have that kind of communication and cooperation as well. So this is what you get out of the evolved cloud operating system. The things you actually already know about. I don't have to spend much time on this slide because you're here because you understand this. You're here because you wanted some system that would provide this kind of thing to your software so your software didn't have to do it for itself. So you didn't just throw the baby out when it was born and make it fend for itself in every possible way so that the creature, the organism could, be supported by the environment while it did the things it was really born to do. Well, again, whatever business purpose you're trying to really solve for. So ecos plus ASMs plus nexus, ecosphere, sorry. This is the essence of this whole proposal is that these things together are bigger than the sum of their parts. Okay? You can't separate the organisms from their environment, okay? And you can't separate the environment from the organisms. That both evolve together. And I believe that what we're putting together, and the reason that you guys are here is because this is so powerful. It is going to expand the ability for you designers to build and create new kinds of organisms. So this is the business value for anybody who's learning to use Temporal and for the company that's committing to Temporal. If you're going to commit to mission critical stuff to a platform, you want a platform that's got some runway ahead of it. And not much talk has been going into what is the runway ahead of you at Temporal, right? So I hope that my little talk has given you some insights into the future. It's not just I'm going to be able to run your workflows faster tomorrow. It's not just I'm going to be able to do, maybe update with start, right? Is a great new feature, but the bigger picture matters too, and I wanted to spend some time with you talking about that. One last thing, again, the environment feeding back on the ecosphere as a whole is that we really need a contribution from you in terms of feedback about what you'd like us to be building here. Okay, so I really want to open up that door as an option for you to come and talk to your sales rep or software engineering or support channel or whatever with ideas for ASMs that you'd like to build. We have two today. You may not even be aware of it. We have Schedule, which is itself an ASM, okay, and we have Workflow. There will be more in the future. And in fact, we wrote Nexus itself inside the architecture as an ASM. So it's a very powerful kind of approach to designing software. That's it for my talk. Remember that the software world is a world of survival of the fittest. Okay, you have to carve out your niche, and the tools you choose to do that with matter a lot. Okay, so I plan, and everyone at Temporal plans to build you the most powerful tools imaginable, so that you can outcompete your competitor, outcompete the rest of the environment, and be successful. Welcome to the new Cambrian explosion.